morning, everyone. Hope you all safe with a good health. With you, Ms. Dina Al-Badri, science teacher for grade 5. Today, we will complete our lesson. What are Newton's law? We talked last time about Newton's first law, Newton's second law, and we know the difference between them. Today, we will talk about the Newton's third law. Newton's third law, he states that motion states that whenever one object apply force to another, the second object apply an equal opposite force to the first object. Did you see? Did you see in this picture? When he start to jump, what will happen to the boat? Yeah, it moves backward. Did you see the rocket? When the rocket moves up, what will happen? Yeah, it make a pump. This pump, it make a force to help the rocket to move upward, and this pump move. Yeah, this pump, this reaction which happen here, move downward. So in the Newton's third law, we say that expression say that the force works in pairs. The force works in pairs. In other words, this law says that the force always acts in pairs. Okay, every reaction has a reaction. Sometimes scientists use the term action force and reaction force to refer to the pair of the forces. In other words, the two forces described above are equal in size and opposite in direction. For example, when aligning against the wall, your body applies force to the wall. That wall doesn't move because it applied the same amount of the force. We said from the first lesson forces, when two bodies act on each other with the same force, there is no motion. Okay? Did you see this rocket? During takeoff, the rockets push the exhaust gases downward, as the gases push the rockets upward with an equal forces. Okay, did you see here the apples? Look carefully at the diagram of the apple and the table. Draw arrow to show the force between apples and the table. Make longer line to show stronger forces. Which one had the stronger forces? Yeah, the third one. Then you see here, yeah, this. Okay, motion in the space. We say that the bodies in the space appears to be weightless, like there is no weight. To understand the motion of the object in the space, it's important to remember the difference between weight and mass. The weight, yeah, it's related to the gravitational force, but the mass is the amount of the object inside the body. Mass refers to how much matter in an object, but the weight refers to how much force is applied to an object by the gravity. By the way, gravity is the types of force. So when we say by gravity or by forces of gravity, both of them is correct. Okay, so when I ask you what is the difference between mass and weight, mass refers to how much matter is in an object. Weight refers to how much force is applied to an object by gravity. Okay. Newton's law of motion apply to object in the space because the laws involves mass, not weight. Okay, so Newton's law apply to object in the space. Okay, so the Newton's law can we use it in the space? No problem. The mass of an object is the same on Earth and in the space because the mass doesn't change. Mass of your body on Earth like the mass of your body on Moon or another planet. But what it will be different from place to another place? Your weight. Because your weight related to the gravitational force, and we have to know the gravity on Earth different from the gravity on Moon, different from the gravity on other planet like Mars, like Neptune, like any planet. So an object weight can change because the weight is related to the forces of gravity at a particular location. Okay, do you see? Yeah, astronauts fell and look weightless because of microgravity. What do you mean of the word microgravity? Microgravity, it means there is no gravity, there is a little bit gravity occurs because Earth's gravity caused the space station to fall towards Earth at a constant rate. Everything inside the space station falls at the same rate. Okay, so when I ask you why these people act like this, because there is no gravity in the space. We call it microgravity in the space. Okay, motion in the space because astronauts are also in free fall. They appear to float. Did you see float? It means they float. There is no weight, flying. Okay, that's all. Hope you all understand. Next time, inshallah, we will solve the worksheets. Watch the video carefully about the Newton's third law. Goodbye.
There are a lot of things happening in the world. Objects move, fall, and rest all around us. You may think you understand why things move or don't move. But did you know that the forces acting on these objects can be measured and their motion predicted? Renowned English scientist Sir Isaac Newton wanted to understand the world better. He thought he could describe the movements of the universe through mathematical observation. In 1687, he published these observations in a book, which outlined his understanding of the laws of motion. These 3 laws of motion are still in use today and can help us understand the relationship between a body and the forces acting on it. Newton's first law of motion is often stated as, an object in motion will stay in motion, and an object at rest will stay at rest, unless acted upon by an outside force. This law is also called the law of inertia, since inertia is the tendency of an object to keep doing what it's doing. You have experienced Newton's first law if you have ever used a swing on a playground. In order to start swinging, you have to use a lot of force, but once you get going, it can be hard to stop. Here on Earth, there are some forces working on objects all the time. When you throw a ball upward, it doesn't keep going up forever because the force of gravity pulls it downward. Once it hits the ground, friction, or resistance caused by surfaces rubbing together, will eventually bring it to a stop. Newton's second law says that force is the product of mass times acceleration. Mass is the amount of matter, or stuff, in an object. To make something accelerate or speed up, you have to apply a force. The amount of force it takes to move an object changes depending on how massive it is. Think about it. You would need more force to move a bowling ball than to move a beach ball of the same size. The greater the mass of the object, the more force it will take to accelerate the object, and applying more force will make the object move faster. Newton's third law of motion says that for every action, there is an equal and opposite reaction. If you exert a force on an object, it exerts an equal force back on you. For example, a ball hitting the ground exerts force downward. The floor exerts an equal force upward. This is the principle that allows rockets to launch or jellyfish to swim. By exerting a force downward, an equal and opposite force pushes upward, and the object accelerates. We can also see the third law in action when birds fly. Their wings press down against the air. The air pushes up against their wings, allowing them to move upwards. Another good example of this law is skateboarding. The skater pushes backwards against the ground with their foot. The ground pushes forward with equal force. Since the wheels of the skateboard reduce the friction between the person and the ground, they are able to move forward for some time before forces slow them down again. Although these three laws were written down more than 300 years ago, they are still important now for understanding the way things move and represent the foundation of classical mechanics. I hope you enjoyed learning about Newton's 3 laws of motion today. Goodbye till next time.